Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. This video is going to focus on some key features of graphing polynomial functions, not necessarily on the graphs themselves, but just a general idea of what's going on. First of all, a reminder, they are a function. So because they are a function, they will be passing the vertical line test. So we're going to be looking at some vocab and what that's going to mean. You're going to hear me talk in general, and I will use these words a lot, about a constant, linear, quadratic, cubic, and quartic. After quartic, I'm not going to really go into the special vocab words. There are examples of larger vocab words. I'm just going to stop there. So what might an equation look like that is a constant equation? It might look like y equals 5. It's constant, there's no variable, things like that. So in other words, it's y equals a number. Linear, we've heard this before, line, right? So that's going to be like y equals 4x. Or anything that can be written in the form mx plus b. I'll let that refocus here. There we go. Quadratic, we might see y equals 8x squared plus 3. The big deal here is that squared, so we might see something like ax squared plus bx plus c. But again, that x squared term must be there, just like the x must be here. Without the x, it's just a number, right? Cubic, y equals x cubed. Okay, so generically that's something x cubed plus something x squared plus something x plus something else. Quartic is going to be like 5x to the 4th plus 2x squared minus 8. It has to have that x to the 4th power. Okay. So when looking at equations, you need to know the degree. And these are polynomials. In this case, constant has a degree of 0, linear has a degree of 1, quadratic has a degree 2, cubic has a degree 3, and quartic has a degree 4. The reason why this is a degree 1 is because the highest power is 1, x to the 1st. Here, the highest power is 2, x squared. Here, the highest power is 3, x cubed, and 4. You'll notice there's not an x here. That's because it's x to the 0. And if you remember, x to the 0 is 1. Anything to the 0 power is 1. Why is that? Well, let's think about this. I'm sure you agree that 5 divided by 5 is 1. 12 divided by 12 is 1. X to the 3rd divided by x to the 3rd is also 1. Anything divided by itself is 1. However, if you recall, division of polynomials means we subtract exponents. And 3 minus 3 is 0. So that's why anything to the 0 power is 1, because it's like something divided by itself. So, little side note, but in case you were wondering why x to the 0 power is 1, that's why. Okay. So we need to make sure that we know our vocab about the equation, and we know vocab about the degree. Now we are strictly talking about the degree of a polynomial, If you have mixed variables, that brings a different part into the degree. So we are just talking about functions in this realm as highest exponent. So you might see a polynomial that looks like this. Okay, so we're going to classify it by the number of terms and the degree. Now the vocab usually comes from the number of terms. Okay, what are terms? Well, terms are the groups separated by plus and minus signs. So 1, 2, 3, 4, 5. There are 5 terms. We don't normally have a vocab word for 5 terms. We would if there were 2 terms, like 2 terms is a binomial, a trinomial. We can utilize terms of 5. However, I generally do not ask students to know those words, so I just say it's a polynomial with 5 terms. Now you might notice that this is not written in standard form. Standard form would have us writing them in descending order. So, meaning you start with the highest power and work down. So in our case, the highest power is 7. So we would start off with negative 10 x to the 7th. Then our next highest is x to the 5th. That's positive. The sign goes with it, right? Then x to the 4th. Then the x to the cubed, x to the cubed, x cubed. And then the linear. Okay, now it's written in standard form. So our highest power was 7. So the degree is 7. And I'm not going to have a special vocab word for it either. Now this is the quartic term, the cubic term, the linear term. But the bigger the exponents, I don't utilize those vocab words on a daily basis. Okay, again, standard form, we did descending order. Now, a coefficient is a reminder that that's the number in front of the variable, and the lead coefficient has a lot of power in shaping your graph. Our lead coefficient is negative 10. This being negative tells us something very important about the graph, and we are going to be getting to it. And the degree also tells us something very important about the graph. Those two things are actually going to help us figure out a lot to the graph shape. So that's what we're going to go ahead and explore. We're going to go ahead and look at some generic shapes of both graphs, and we are going to draw them as crazy as they can get. However, we're also going to assume that it has a positive lead coefficient, the a value being greater than 0. The only one that really stands alone is the constant, which is the degree 0, because it's a flat line. It really doesn't technically have an a value because it doesn't have a coefficient. So we are going to keep that one completely separate. So remember, if you have a constant, it stays flat, it flat lines, degree 0. It's just in its own little world. The other ones that we're going to look at, we're going to go all the way through degree 6. Okay? So I'm not going to draw the coordinate plane because I'm not worried about that at this point in time. I'm more worried about the shape. So again, we are assuming that it has a positive lead coefficient. Remember, negative lead coefficient, you might have found in one of my earlier videos, reflects everything upside down. So keep that in mind. We're assuming that it is a positive. So a value being 1 or a positive slope, we know a line does this. Okay, uphill, moving from left to right. In previous videos, we've also graphed quadratics or parabolas, and we've talked about how when a is greater than 0, it's positive or happy, so we get that parabola that's a happy face. The ones that I have not discussed as of yet in my videos are going to be the other shapes going on here. So the wackiest that this can get, and that's what I'm drawing for all of these. There would be an example of a cubic graph. Quartic. Quintic, in case you wanted to know. So now it's just kind of an idea of what do you notice? So the first thing we're going to talk about is the curves. Curves, also known as turning points. So we're going to be doing turning points. So here, the number of turning points, since it's straight, it doesn't have any curves, so the turning points is 0. Here we just come down, we turn, and we come back up, so it has 1 turning point. Cubic, we come up, then we come down, we go back up, so there's 2 curves, so there's 2 turning points. Here, quartic, we had 3 turning points. Degree 5 has 1, 2, 3, 4. 4 turning points, and degree 6, 1, 2, 3, 4, 5. Now, this is just the max number of turning points. They could have less. They could not be this wacky. So, do you notice a relationship between the max number of turning points and the degree? Zero to 1, 1 to 2, 2 to 3, 3 to 4. Yeah. Your max turning point equals your degree minus 1. Again, you could turn fewer times, but you can't turn more. Okay. Now I'm going to go through and I'm going to look at the right side of the graph. Pointing up, pointing up, pointing up, pointing up, pointing up, pointing up. All the right sides of the graphs were pointing up. Okay? That's because a is greater than 1. So when a is greater than 1, or positive, the right side will point up. Now you're often going to see it written as x goes to the right, which would be infinity, y goes up to infinity, right and up. However, and by the way, if a were negative, then this would be down, because negative people eventually will bring you down. Positive people will eventually drag you up. Negative people will drag you down. Okay? So, positive a ends in the positive quadrant. What do you notice about the left side? Down, up, down, up, down, up. So when the degree was odd, when it was an odd degree, it was down. When it was an even degree, it was up. So left side would be x being negative infinity, right? Here, when x went left, y went down. Here, when x went left, y went up. And I'm going to explain those little arrow notations better here in just a second. But here's the big deal. If we have an even degree, 2, 2, 4, 6, the arrows match. When we have an odd degree, they're opposites. So even, they're even, odd, they're opposites. Okay? So when we had that problem just a moment ago, the degree was 7 and the lead coefficient was negative. So up to 6 turns, but this is negative. Negative people eventually bring you down. And the degree is odd, so that means it's going to start up. There's 1, 2, 3, 4, 5, 6 curves, right? Here's my 6th curve. There we go. So the graph could look something like that. Now the hills might not all be even, some might be steeper than others, some might be taller than others, but in general that's what's going to happen. It's going to put down on the right because of the negative lead coefficient. They're going to be opposites because this is an odd degree. Those two things tell us a big deal about the overall shape of the graph. Now, as far as those little weird arrows things go, I think we would all agree that the ordered pairs here are positive, positive. Here they're negative, comma, positive. Negative, negative, and positive, negative. So for a graph that looks like this, it ends in this quadrant, starts in that quadrant and ends in this quadrant. All I'm doing is saying for the left side, as x goes to negative infinity, y goes to positive infinity. See how we're using the ordered pair signs, negative, positive? Here, as x goes to positive infinity, y also goes to positive infinity. So because the arrows were in quadrants 1 and 2, I use the signs from quadrant 1 and 2. Okay. So let's say this was my graph. Now this is quadrant 2, where it's negative, comma, positive. And this is quadrant 4, where it's positive, comma, negative. So for my end behavior, my left side, as x goes negative, y goes positive. My right side, as x goes positive, y goes negative. So to get that direction approach notation, that's what it's called, direction approach, I'm just using infinities after the symbols or the signs of what the ordered pairs would be in that quadrant. Okay, direction approach notation to describe what we just described is end behavior, or the arrows. What are the arrows doing? Okay, and we did discuss that odd degree, the ends are opposites. In other words, one arrow is going up, the other arrow is going down. With even degree, the ends match. Okay. If a is greater than 0, the right side is up, or positive infinity, positive infinity. If a is less than 0, negative people bring you down. The right side is down, i.e. this ends in quadrant 1 versus quadrant 4. Okay. And another thing they might ask you for is the rate of change. It's another thing they like to talk about in sections like these. Rate of change is a fancy way of saying slope. y2 minus y1 over x2 minus x1. That formula's been around for you probably since junior high. You might find textbooks go ahead and describe an image to you, and they want you to draw it. In this case, they want you to draw a function that is positive on intervals, and they give you 2 intervals. Those are not ordered pairs, those are sections. Anytime they talk about intervals, they're giving you the domain of the interval, meaning x values. So what they're saying is positive between -2 and -1. So what does positive mean instead of increasing? Because on line 1, we see that it needs to be positive, but on line 3, we see that it needs to be increasing. So positive would be greater than 0 or above the x-axis. Okay? Negative would therefore be below the x-axis. So I'm just going to take a little number line and talk about those 2 things. Okay? Here's a number line. So they want us to be positive between -2 and -1. And then between 1 and 2. And then they want us to be negative or below between -infinity and -2, between -1 and 1, and between 2 and infinity. So they want us to be below, then above, below, above, and then below again. Okay? So I'm just going to kind of sketch that. Below, above, below, above, below. Oh, keep going down. Okay, well, let's see if that works with increasing, because increasing means you have a positive slope. Okay? So -1.5 would be there. They want us increasing. Between there and here. Between, let's see. Let me draw that similar to how I did before. We'll ignore this little step right here. And we'll scratch that out. So, increasing from -infinity to -1.5. So they want us increasing, and then they want us to skip over to 0 and positive 1.5 and be increasing again. -1.5 to 0, they want us decreasing or downhill, and then 1.5 and on. Well, let's see. Did I go increasing, decreasing, increasing, decreasing? Absolutely. Did I switch at -1.5, 0, and 1.5? It actually looks like I naturally did. Okay, let's just make this a little bit prettier then. Okay. Since they didn't tell us actual values for the y, that doesn't matter. Okay, but we do know our x-intercepts because that's where we switch from increasing to decreasing. So, sorry, not increasing to decreasing, positive to negative. Whew, helps if I use my vocab words. So here's -2. -1, 1, and 2. Those are our x-intercepts because that's where we switch from positive to negative. Below, above, below, above, below. Okay, same shape as I drew right here. I made sure that I switched at -1.5, 0, and positive 1.5. That's where I switch my slope from positive to negative or from increasing to decreasing. Okay, what kind of graph is this? Well, it would happen to be a quartic graph. Okay. The reason why it's probably a quartic graph is we see 3 turns and the arrows match. Therefore, it's an even degree. So we're going to go with degree 4. Because the right side is pointing down, it has a negative lead coefficient. In fact, a cool, neat thing is that we could actually say that this is a sample graph would be y equals -1. Since it has a 0 at -2, since it has a 0 at -1, since it has a 0 at +1, and that's just taking what we learned in previous videos about quadratics and solving quadratics by looking at the x-intercepts or factoring and how that related to the graph. The zeros and everything regulate. And you'll notice that we have 4 parentheses. We could go ahead and multiply it out and get a nice pretty polynomial. The left side is x is negative, y is negative. And that's because we're in quadrant 3 where it's negative, comma, negative. The right side is negative as well. That's because it ends in this quadrant where it's positive, comma, negative. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.